Hello everyone, I'm Pavel Odintsov, and in this presentation I will talk about network telemetry. And in this presentation I will share my experience and my knowledge collected through running a project for fast open source DDoS detection, FastNetMon. And in this presentation we will focus only on specific things very important for DDoS detection. So because network telemetry is quite complex and sophisticated areas, because when it introduced back in time, it was implemented for very different purposes. So because all of us, we have very different reasons to enable network telemetry in our networks. Sometimes we just need to improve peering. Sometimes we need more visibility about what's going on in our network. And sometimes we need to detect DDoS. And in every such case, it's very important to focus on specific things, on specific benefits or issues caused by different network telemetry protocols. So let's start from the beginning. What kind of telemetry protocols types we have? So because all of us, we live in modern age and we can split them into options. So on-premise, in cloud. It's quite a weak way to distinguish them, but it's clear. In first case, you have access for your equipment. So you're a network operator, you have access to switches, routers. You can change and define your routing policy. You can change configuration of your equipment. In second case, it's more like API, which can be used for receiving information delivered by cloud. But in this case, you have no access for equipment. That's way how we can distinguish it. And of course, we will start from on-premise. And one of the most popular and widespread protocols, of course, it's NetFlow. You may hear it, you may use it. And sometimes you can see it in different names because NetFlow, it's trademark. And you may hear it as CFlow, NetStream, JFlow, or wide range of different vendor-specific names. It's one of the oldest protocols, and it's one of the most popular protocols you can find out on your equipment. But typically when I mention like equipment, typically you can find it in routers. In quite rare cases, you can find it in switches. And as you can guess by name, NetFlow operates on flow level. And in our case, flow level is 5-tuple, which means source IP, destination IP, source port, destination port, and protocol ID. And to aggregate multiple packets which belong to same flow, we need some way of merging existing same flows, because for example, if we have multiple applications working in exchanging packets quite frequently, instead of sending NetFlow telemetry about like thousands of packets, we will try to merge them and aggregate them. And you may guess, when we mentioned aggregation, and it's quite complicated process. And unfortunately, aggregation means we need some way to track information. And it may cause more problems for hardware side and software side. And of course, second by popularity protocol is SFlow, which is quite widespread. You can see on my slide numbers about collected through the customer base of FastNetMon. You can see NetFlow is most popular, SFlow getting second place. But I would say that SFlow is not very well-known protocol, but it's a really good protocol. So if you have it and if you haven't tried it, I would recommend to look precisely on it and try it, because maybe for your case, it works much better. And last resort option is span port. Actually, it may be implemented in a port mirror on your switch or router, or actually it may be implemented using hardware, optical splitters. And it's almost always how we can capture traffic for now. And in this case, when we talk about telemetry, because telemetry terminology is very overloaded, because it can mean that it's some way to export port counters, interface counters. But in this specific presentation, we focus on way how we can have routers or switches or different kind of network equipment can send information about flows, what actually going on, what kind of packets we see. And let's focus on NetFlow. As I said, you may experience different names for NetFlow-based protocols. And unfortunately, protocol versions NetFlow 5 and 9, they have no good standardization. So because was implemented by Cisco, and you may find different ways how different vendors actually understand what it was what was root cause of specific field, what was encoding way for specific field, and that for perspective of NetFlow collector implementation, it causes quite serious amount of problem because you actually cannot find information about what's going on and what kind of encoding you need to use to decode the information in this field. And one of the ways forward, of course, it was introduction of IPFix protocol. And sometimes in very old documentation, you may find out that like IPFix mentioned as NetFlow 10. And it's quite logic way to name it because what main things from IPFix, which distinguish it from NetFlow 9, is very well RFC, describing every way how it encodes information, what kind of fields we have, what's purpose of specific field, how you can decode it. It's really great step forward for the development of NetFlow collectors because it provides way and unified way how you can receive information from equipment and without going into specific for vendor details. But of course, for DDoS detection purposes, we have quite serious number of issues in NetFlow protocol. That's why in the start of my presentation, I mentioned that different application of Network Telemetry, they have very different purposes. And for each case, you may have issues or some things can benefit you seriously. Because NetFlow is based on aggregation. It's in DNA of this protocol. So we need some way, some system in your router. It can be hardware or software to track number of existing flows in your network, and it may be very resource consumptive process because for typical network, maybe with multiple 100G ports, it's quite expected to see millions of active flows at any time. And it causes many problems because for its finite resource. And in this presentation, we are talking about DDoS. And if I talk about finite resource, so your router may have limit for like few millions or actually few hundreds of thousands flows. And then if you run out of them, and attacker can do it artificially by, for example, creating random source ports, random destination ports. And after that, all kinds of bad things may happen. For hardware routers, of course, you will just lose visibility, what's going on in your network because the router will stop exporting information and generating NetFlow information about what new flows we have. What, is it legit flow or is it some malicious traffic? And in case of software routers, it's actually much worse because you actually it may cause connectivity issues or problems with packet forwarding because in case of software routers, NetFlow processing and forwarding actually use same CPU, which can be easily overloaded by NetFlow itself. And one more issue is in NetFlow, because for example, for NetFlow 5, please, if you still use NetFlow 5, almost all equipment which has support for NetFlow 5 also has support for NetFlow 9 or IPFix. Please move away from NetFlow 5 because one of the worst things in NetFlow 5 you can experience, it's absolute lack of information about IPv6. It just has no fields to encode IPv6 addresses, not source, not destination. Please move away from it if you can. If you are talking more about modern protocols, NetFlow 9 or IPFix, different vendors may implement different fields. Of course, you can expect some minimum list of fields you can find, like source port, destination ports, sometimes TTL fields. Some vendors actually can provide information about not about level 3. It's like MAC address, but unfortunately, it's still lack of plenty of useful cases. For example, if you're looking for VXLANs, GRIA in internal packets, outer packets, or MPLS, or you can use some new modern way how you can actually use encode traffic or tunnel traffic in your network. In this case, NetFlow or IPFix cannot help you because in this case, you need to escalate this problem to your vendor and wait months, years, maybe decades to implement them. And it's quite serious problem because for DDoS detection purpose, we need to understand what's actually inside of packet to guess, like, is it malicious traffic or is it legit traffic? And of course, because of need to maintain every single flow which passing leaving your network or arriving into your network. It causes scalability problems, and it's quite complicated, and sometimes actually you need to buy additional equipment from hardware perspective to implement as net flow without sampling. If you want every single flow for 100G interface, it's a challenge, and it's one of the first things you need to put for requirements for your new router. And sampling rate reporting, it's not very big issue for IPFix protocol, because IPFix has quite good standards which explain how routers can encode sampling rate. Because in big network you may have different segments or different routers using a little bit different sampling rate, and it's for collector side and for DDoS detection of purposes. Of course, we need to know all of them, because before we can calculate proper bandwidth, we need to multiply received flow packet, number of packets, number of bytes by sampling rate. But for NetFlow 9, it's very complicated, because different vendors use a little bit different way to encode it, and it becomes very challenging. So, and if you want to try, because if you operate a network which is running in the same vendor, you may actually try to implement NetFlow collector by yourself, because it's not rocket science. You can create maybe Go application or Rust application which actually receives NetFlow information from your routers, process it, calculates spikes, calculates malicious traffic. But if you operate single vendor, it may work. But if you have multiple vendors, as all of us have, it may become as your nightmare, because small difference, small way to a little bit different in code. And it's actually became very challenging. That's why it's very beneficial for you to have like projects like FastNetMon, because you can just use it and you reuse our parsers, reuse our experience collected through the many years and many broken vendor implementation of the telemetry protocols. And from discussion about sampling, let's move to next protocol, SFlow. I don't want to hide it. It's my favorite protocol. It may not work for all applications. You cannot replace it for NetFlow or IPFix by SFlow. For example, for purposes, if you just need traffic accounting, you need to understand for audit purposes, for SIEM purposes, to understand like which host was visited by this customer or this port. But it provides really great foundation for DDoS detection, because in SFlow name, what's wrong with this name? It's very misleading name, because it feels like NetFlow and SFlow are similar, because both of them have a flow in name, but actually extremely misleading. As someone recently mentioned on Twitter, SFlow should have name as packet, because SFlow doesn't operate on flow. We have nothing about flows. It doesn't aggregate flows. It doesn't collect flows. It doesn't track flows. And it's just very simple implementation of sampler. And for every 1,000 packets observed from interface, select one of them, use very simple encoding, cut first X bytes, typically it's between 80 or 120 bytes of original packet, and send to collector. It's extremely simple. We have no delays, because we don't need to wait until this specific flow finishes. We don't need serious amount of memory for flow tracking. We don't need extremely expensive hardware memory for flow tracking. It's just what we observed and immediately send it. And typically for switches that implemented on hardware and from control plane, it just observes sampled packets, which needed to be just collected and forwarded to sampler. Next benefit of SFlow, as I mentioned, NetFlow or IPFix protocol are very heavy. You need to maintain table of flows. You need to age flows. You need to track how many packets for every flow we have. Is it like terminated? Is it terminated by timeout? Is it terminated by maybe thin packet? It's quite a sophisticated process. And fortunately for SFlow, we don't need it. And also we have a very simple way to encode sampling. No complex templates, no complex vendor-specific ways how you can extract information about sampling rate. Only one thing is you just have it exactly in packet. When you receive like any SFlow packet, in just near of packet header,
which actually is kept here without any kind of encoding. You have sampling rate, just multiply one of them to number of packets, and here you go, you have real bandwidth. It's very beneficial. It may sound tricky because instead of having like source port, destination port, we have packet header, first X bytes. For one purpose, of course, it's complicated for you, but it provides lots of, it just moves complexity from router to collector. And it's not simple to replace your core routers in production network. To add some new features for IPFix or NetFlow, even just attempt to change firmware sometimes can take ages. And everyone knows about it. It's very complex. And in this case, for SFlow, we just send everything as we see. Like new protocol, VXLAN fine, MPLS fine, and then we just push complexity of implementation into NetFlow collector. In some cases, it works. And I think it's very beneficial. And what we can do in this case, what kind of problems we have with Flow? It was like marketing speech, like everyone, please buy SFlow. Unfortunately, it's not that great. Because implementation and protocol for SFlow is really nice, simple, transparent, very simple for engineers and developers who are in charge of NetFlow collectors. But problem is vendors. Unfortunately, quite often we can see case when a switch vendor tries to save, I don't know how much, maybe $10, and they just use extremely slow CPUs for control plane on switches. And as a consequence, they even cannot handle and export traffic sampled with very heavy sampling rates to a SFlow collector, because if you enable reasonable sampling rate 1 to 1000, which is really good for networks with about 10G or like even 40G, some vendors, and I don't want to mention some names, but all of them are very well known. So sometimes they just cannot afford setting this specific sampling rate. And if you set it, you can notice that like your control plane is constantly overloaded, and it may drop packets, and you may lose visibility about what's going on in your network. And next issue is just lack of SFlow support. It's really great to see that some vendors, I would mention Juniper and Huawei, they actually have support for NetFlow and SFlow at the same time on same routers. I think that's really great because you just provide more options for your customer to select what is the best protocol, because you can see they're very different with very different purposes. For some customers, SFlow works fine. For some customers, only NetFlow works fine. But if you can put aside issues mentioned here, and if you own quite modern router, it will work fine for you. I would recommend, if you haven't tried SFlow, try it. It's a really great protocol. And last resort, what we can do if you don't have NetFlow, SFlow, IPFix in our network? Linux for the win, because in worst case, we can just mirror using switch capabilities, all traffic of specific port. Typically, it's your upstream. And then we can process every single packet. Of course, you can understand that it will require lots of CPU resources. But fortunately, in modern Linux kernels, we have such technologies as IFPacket, AFXDP, which is actually very beneficial because it uses zero-copy approach, and many other ways how you can capture traffic. Because I focused in this presentation on AFPacket and AFXDP, because in this case, you don't need any libraries, no commercial dev kits, no license, no special SDK from your vendor of smart NIC cards. You just need Linux box. I think it's really great. Just install latest Ubuntu or Debian, and here you go. It just works. You don't need any libraries. You don't need any special kernel modules, because it's pain to maintain them, update them all the time, keep your eye on it if it's even worse. It's a custom one. This one in Linux kernel works on really any platform. ARM box, PowerPC box. Fine, it works. And next, you may guess it. Yes, this one is my favorite. If your router or your switch or security device implements SFlow properly, it's really great and use SFlow. It's one of the best protocols you can see for DDoS detection. Of course, it has issues, but if you compare it with different available network telemetry protocols, this one is definitely the best one. And what we have else here, we have cloud. In case of cloud, it's it's very brief because not so much we are going to talk about, because in this case, cloud telemetry from Amazon, Google, or Azure, it's just service. We don't know how they implement flow aggregation. Is it flow or is it packet? What kind of sampling rate we have? We just users. We just click buttons in web UI and expect something in exchange. This list is ordered by convenience of using cloud network telemetry. Of course, Amazon is the best. I may hear, not all people may confirm it, but it's really great because it's only one system which actually offers complete visibility of your traffic. You can see information about UDP, JRE, and any even unknown protocols in your cloud infrastructure. It's not limited by TCP and UDP. And one of the issues for it is 60-second delay, because in case of DDoS, it's very important to keep this delay as short as you can, but for Amazon, you cannot. So you will receive information about enormous DDoS hitting your cloud infrastructure in 60 seconds. Sometimes you can wait, sometimes you cannot. And what next? Google, they provide very similar pipeline for exporting telemetry. And so you can create pub/sub interface to receive information, and you will see all packets arriving, all packets leaving. It's actually not packets, are flows. But one of the main issues for Google, and Google, please fix it. You have no visibility for non-TCP and UDP protocols. So if you experience JRE DDoS attack, it will not be reflected in any way in your telemetry. It's really a big issue because it's quite common type of attack. And so it may be new protocol, which will be used as vector for DDoS attack, like maybe BGP. And Azure is third place for reasons, of course, because for Azure, unfortunately, there are no way to export information in real time. Because for Amazon and Google, we can subscribe to feed, which actually sends information about flows as they observe it on your network. But for Azure, only one way to export this information is file. File is not real-time way. Everyone understands that it's actually quite big problem for us. But one of the really nice things what we noticed in Azure, it's actually they offer convenient interface to process this information and create graphs about how much traffic you have for specific country, how much traffic you have for specific network. And it's very beneficial because you cannot find information for different cloud providers. And that's everything. Thank you for listening for my presentation, and I will be happy to answer any questions about network telemetry, because I have really strong passion about network telemetry. All the time I'm trying to follow trends in this industry, trying to find and share feedback with vendors. Questions?
Do we have any questions for Pavel? We'll keep the questions open for 30, 45 seconds. Give you a chance to put one in if you have one.
Any questions?
It looks like we don't have any questions. So you can always reach Pavel in the Mattermost chat during the rest of the meeting or at the social. So thank you very much, Pavel.